Okay, so now let's look at this example. The question says determine the value of velocity at time t equals to 16 seconds using second order polynomial interpolation using Newton's divided difference polynomial method. Okay, so we've generated a general formula, okay, which is what we have here, right? So let's go ahead and then look at how we are going to do this. So in this case, our function will have to be in terms of what t and then v of t, right? So now let's write the general form. So we're going to have v2 of t, okay, and then this will be equal to v of t naught, right, plus v of t1, okay, minus v of t naught over t1 minus what t naught, right? This will be multiplying t minus what t naught, okay, plus v of t2, okay, minus v of what t1, right, divided by t2 minus t1, okay, minus v of t1 minus v of t naught, okay, divided by t1 minus what t naught, okay, all this divided by t2 minus what t naught, right, and then we'll be multiplying t minus t naught, and then also multiply t minus what t1. Okay, so this will be the general form. So we know every other value except this t. Okay, so that's what you have to find. So let's look at that. So we will have to choose 3 data points, right, because this is a second order polynomial function. Okay, and I said I'm going to explain the reason why it is second order, because if we simplify this, okay, you are going to get the highest power of t to be 2. Okay, this is because of what you have here. Okay, just expanding this, you will see that you are going to have t squared there. Okay, so this is the reason why we consider this to be a second order polynomial function. Okay, so let's continue. So you are going to choose 3 data points, okay, and then that data point we will have to choose a range where you can have what the 16 there, right? So I'll consider from 10 to what 20. Okay, so I'm going to have t naught, okay, to be equal to 10, t naught to be equal to 10, and then v of t naught, okay, will be equal to 227.04, right, and then I'm going to have t1, okay, to be equal to 15, and then v of t1 to be equal to 362.78, right, and then I'm going to have t2 to be equal to 20, and then v of what t2 to be equal to 517.35, okay, and then you have t to be equal to what 16. So let's do the substitution and then see what we are going to get. Okay, so we are going to have v2 of 16, okay, to be equal to v of t naught, which is 227.04, plus what v of t1, which would be 362.78, minus what v of t naught, that's minus 227.04, okay, divided by t1 minus what t naught, that would be 15 minus what 10, okay, this multiplying t, which is what 16 minus what t naught, which is what 10, okay, so 16 minus 10, plus let's look at what you're going to have here. We have what v of t2 minus what v of what t1, that will be 517.35 minus what 362.78, right, okay, then we're going to divide this by 20 minus what 15, okay, minus, okay, 362.78 minus 227.04 divided by 15, okay, minus what 10, right, all this divided by 20 minus what 10, okay, they are going to multiply this by 16 minus 10, okay, multiplying 16 minus what 15. Okay, this is what you are going to have. So let's simplify this and see what you are going to get. Okay, so if we simplify this, you are going to get v2 of 16, okay, to be equal to 392.19 meters per second. Okay, so this will be the value for the velocity at what time t equals what 16 seconds. Okay, so this is how to use the Newton's divided difference method, but you see that in this case we had to generate the formula for both the first order polynomial function and the second order polynomial function. Okay, so what if you've been asked to find a third order polynomial function? Okay, using the what if you are asked to perform interpolation using Newton's divided difference method, and then you should use a third order polynomial function? How are you going to do this? So for this reason, you are going to generate a general formula that you can use for the Newton's divided difference polynomial method.